So this is a lab for LO 3.13, and the materials that you require for this lab include 3 beakers, a glass U-tube which will be used as a salt bridge, cotton balls, a multimeter, 2 alligator clips, safety goggles, and 0.5 molar solutions of copper nitrate, zinc nitrate, lead nitrate, and potassium nitrate, as well as the individual strips for the 3 metals. And so here's a diagram of how your lab should be set up. So here you have the U-tube filled with potassium nitrate and stopped with 2 cotton balls that will act as your salt bridge. And here are the 3 beakers filled with copper nitrate, lead nitrate, and zinc nitrate with their respective metal strips into each beaker. Next, you want to take your salt bridge and you want to invert it and place it into each beaker that have the alligator clips attached to it. And you want to do this for each pairing of metals, which are copper and zinc, copper and lead and zinc. In the event that your multimeter reads a negative number, you want to switch to alligator clips and record that number into your data table.
This is the lab for learning objective 3.12. The materials necessary for this lab include 2 copper strips, copper sulfate solution, sandpaper, analytical balance, beaker, distilled water and wash bottle, paper towels, a rinse beaker for distilled water and a rinse beaker for acetone, an ammeter, 3 alligator clips, a power supply, a timer, forceps, and scissors. Once you have all the materials, use the scissors to round off the top edge of one of the copper strips. Polish copper strips with sandpaper and wipe them with a clean paper towel. Rinse both strips with distilled water and pat dry. Then use the forceps to dip the strips in a beaker containing alcohol or acetone. Remove the copper strips and allow it to air dry. After they are done air drying, use the analytical balance to record the mass of the copper strips. Pour about 80 milliliters of copper sulfate solution into a beaker. Then place the 2 copper strips in with the forceps. Next, use the alligator clips and connect the positive lead of the power supply to the anode, also known as the rounded-edged copper strip. Connect the positive lead on the ammeter to the cathode, known as the other copper strip, and then connect the negative lead of the ammeter to the negative lead of the power supply. Finally, record the initial time and start the timer. This diagram shows what your experiment should look like and labels the anode and the cathode, which are the electrodes in this experiment. Make sure that the top of the copper strips are bent over the sides of the beaker to hold the electrodes in place. This is necessary to obtain a stable current. Record the currents at 1-minute intervals for about 18 to 20 minutes. Then record the final time at the end of the electrolysis reaction. Disconnect the alligator clips from the electrodes. Dip each electrode into a beaker of distilled water and then into a beaker of alcohol. Place the electrodes on a paper towel and allow them to air dry. When the copper strips are dry, record the mass of each electrode.